Today we're going to graph some parabolas. So this first one is written in what's called vertex form, or graphing form. So graphing form looks like this. Y equals a times the quantity x opposite h squared plus k. So we're looking for three things, a, h, and k. H and k tell us where the vertex of the graph is located. Where a tells us about the shape and the direction the graph opens. All right, so right here, I see h and k. H is a positive 4 and k is a negative 5. So if you just match everything, we've got x and x, negative sign, so h must be that 4. And we have this squared. Then right here it says negative 5, but it's supposed to be a plus k. So that tells us k is negative 5. So we know the vertex is located at 4, negative 5. Now let's look for a. There's nothing written here. And when nothing's written in multiplication, it's a 1. So there's a 1 right there. So this tells us this is the standard mother function parabola. There's no stretch, and we also know it opens up. So if we jump to a graph here, all right, so far we know that the vertex is at 4, negative 5. So 1, 2, 3, 4, negative 5. 1, 2, 3, 4, 5. That's the vertex. And we know it opens up, so it's going to look something like this. Let's find a few more points. To find more points, make an XY table. So X, Y. I'm going to put the 4, negative 5 right in the middle. So with the input of 4, we get negative 5, and that's our vertex. It's actually the lowest point on our graph. So what happens at, let's say, 3, and what happens at 5? So if we substitute a 3 into our original equation, 3 minus 4 is negative 1. Square it, you get a positive 1. And then minus 5, we get negative 4 as an output. When you substitute a 5 in, you also get negative 4. Let's do another point. How about an input of 2, and we'll do an input of 6. So if we substitute a 2 in, 2 minus 4 is negative 2. Square it, we get a positive 4. Positive 4 minus 5 is negative 1. And you actually get a negative 1 here for the 6. Parabolas have symmetry, so from the vertex you can see how the vertex is kind of the middle here, and then we have negative 4, negative 4. We have negative 1, negative 1. So whatever this next output will be at 7, it will match the output at 1. Let's actually find it. So 1 minus 4 is negative 3. Negative 3 squared is 9. 9 minus 5 is 4. So now we have a bunch of points we can actually graph. So let's go back to our graph here. All right. We already have the vertex, so that one's already graphed right here. So we have 3, negative 4. So 1, 2, 3, negative 4. Then we have 5, negative 4. Then we have 2, negative 1. And we have 6, negative 1. Then we have 7, 4, and 1, 4. All right, so here's what our parabola looks like so far. Cool. Let's do another one. So on this one, our a value is a 2. It looks like our h is a negative 2, and our k is a negative 5. So this 2 tells us our graph is going to be narrower, and it opens up. So these tell us our vertex is at negative 2, negative 5. So even though this is a positive 2 right here, the h is always the opposite of what it appears. Because if we look at graphing form, see that opposite h? So what value would have to be here so when we subtract it, we get a +2? It'd have to be a -2. So that's where that -2 comes from. But we don't have the same situation with the k. It's just a +k. So whatever this is what it is in the vertex. All right, so let's just start with the table. We already know this stuff about it. The vertex is at -2, -5. So let's find out what happens at -3 and at -1. Let's start with the -1. -1 plus 2 is 1. 1 squared is 1. Times 2, we're at 2. 2 minus 5 is -3. And because of symmetry, we'll be at -3 there too. Let's do one more point. How about 0 and -4? All right. 0 plus 2 is still 2. 2 squared is 4. Times 2 is 8. 8 minus 5 is 3. All right, let's just graph these coordinates to start. So our vertex is at -2, -5. -2, -5 is right there. We know it opens up and it's narrow. So then we have -3, -3. That's right here. -1, -3. 0, 3. That's way up here. And -4, 3. Oops, I think I did -5, 3. -4, 3 would be right here. So we don't want to graph that point. So here's what we get. Now, if you compare that to the first one we graphed, it's a lot narrower. It's actually twice as narrow. All right, let's try another one. On this one, we have a -1 for the a value. And what that tells us is this is going to open downward, but it's going to have the same shape as the mother function. It's not wider or narrower. Our vertex is at -4, 3. So let's find some other points. All right, if we plug in a -5, we end up with 2 as an output. So this is going to be a 2 as well. And then if we plug in a -2, let's see, -2 plus 4 is +2. +2 squared is 4. 4 times -1 is -4, plus 3 is -1. So there's 5 points. Let's start with those. Our vertex is at -4, 3. 1, 2, 3, 4, 3. -3, 2 is another point. Oh, I'm sorry. -4, 3 would be way up here, because that's not a -3. So that's the wrong point. -3, 2. 1, 2, 3, 2. -5, 2 is right here. Then we have -6, -1. It's way down here. And -2, -1. It's down here. So this one looks like this. You can see the symmetry. There's actually what's called the axis of symmetry right here. It goes right through the vertex. The equation of the axis of symmetry here, we could say the axis of symmetry is x equals -4. That's the equation of this vertical line that runs right through the middle. All right, let's do one more. On this one, our a value is 1/2. Since it's positive, we know it opens up. And the 1/2 means it's wider than the mother function. Our vertex is at, so opposite of this one would be -5, and just use that value as it is too. Okay. So, I mean, you could do a really quick sketch here. -5, 2, 1, 2, 3, 4, 5, 1, 2. Wider and opens up. So maybe it looks something like this. That's kind of what we're expecting. But let's find some more precise points. So if we start with the vertex at -5, 2, we could find some points with lower input values and with higher input values. So let's substitute in this -4 right here. -4 plus 5 is 1. 1 squared is still 1. 1 times 1/2 is 1/2. Plus 2 is 2.5. So that means this is going to be 2.5 as well. Now it's kind of a bummer to not have integers here. They're harder to graph because they're not what's called lattice points. So I wonder if there's inputs we could choose that would cause the outputs to be integers. Like let's try this -3. -3 plus 5 is 2. 2 squared is 4. 4 times 1/2 is 2. And 2 plus 2 is 4. So the input of -3 gave us this nice clean value of output value of 4. So if we think about what numbers we plug in here, we want them to be even. We want the overall output here to be even. So when we multiply it by the 1/2, we still have an integer. So let's see, a -3 was a good idea. I don't think a -2 would give us an integer here. How about a -1? Let's try that. -1 plus 5 is 4. 4 squared is 16. 16 times 1/2 is 8. And 8 plus 2 is 10. So yeah, that gave us a value of 10. So using symmetry again, we don't want to substitute in a -8. We want to substitute in a -9 because that will give us an output of 10. All right, that's more than enough points to get an accurate graph here. So let's see. Our vertex is at -5, 2. 1, 2, 3, 4, 5, 2. Then we have these 2 points here, but because of that 2.5, I'm just going to skip those and jump to these next points. So we have -7, 4. 1, 2, 3, 4, 5, 6, 7, and 4. That's right here. And then we have -3, 4. That's right here. And then we have -9, 10. So -9's way over here, and 10 is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And using symmetry, -1, 10 should be right here. All right, so here's our wider parabola. And there we go.